Consider the weighted voting system, open bracket Q colon 15 comma 8 comma 3 comma 1 close bracket. Find the Banzhaf power distribution of this weighted voting system when A, Q equals 15, B, Q equals 18, C, Q equals 26, D, Q equals 27. So we start with part A, find the Banzhaf power distribution when Q equals 15. What this means is we're going to rewrite our given weighted voting system using the new quota, which is going to be 15. This quota right here is going to go in place of the Q in the weighted voting system. And then we're going to write out the 4 players that are involved in this particular weighted voting system. Player 1 will have a weight of 15, player 2 has a weight of 8, player 3 has a weight of 1, and player 4 has a weight of 1. Now, let's go ahead and understand what all this means. Okay. First off, when we say the quota, that means the number of votes required to carry a motion or pass the motion these particular values right here are the weights for each player. Okay. There are 4 players. And we will identify them as P sub 1, P sub 2, P sub 3, and P sub 4. And these will be the weights within the coalition. Okay. So first we need to understand what each one of these means. If player 1 is equal to 12, is equal to 15, in this particular case, this allows player 1 to be a dictator. The reason that player 1 is a dictator is because it will require just player 1 to be able to pass any motion. Now player 2 is going to have a weight of 8. Player 3 will have a weight of 3. And player 4 will have a weight of 1. And what we're going to do is we're going to identify winning coalitions now. And to identify the winning coalitions, what we're going to do is look at the sums of the weighted votes and make sure that they are greater than or equal to 15. This allows us to have a winning coalition. So we start by looking at what our winning coalitions are going to be. And if we list all 4 of these players together, player 1, player 2, player 3, and player 4, this will be a winning coalition because we take the weights and we add them together. And when we add them together, we're going to get the following value. And that is most definitely greater than or equal to our quota of 15. So this is a winning coalition. And there are going to be a number of winning coalitions. And we need to list all of them in order to fully understand this particular power distribution. So we started with the fact that all 4 of the players can sum together to give a weight of 27, which is greater than or equal to 15. And now we're going to look at all the other different possibilities. We can go with player 1, 2, and 3. And the reason I know that that is a winning coalition is because we will add 15 plus 8 plus 3, which is going to be equal to 26. That is also greater than or equal to 15. And that means it is a winning coalition also. Now we'll do player 1, player 2, and player 4. And that will be equal to 15 plus 8 plus 1. And that is also greater than or equal to 15. So I know that this is also a winning coalition. And we just continue on until we have all of our possible winning coalitions. And now I've listed all the possible winning coalitions. You'll know that it's not a winning coalition if you were to add the numbers of the weighted votes and it comes up to less than your quota. For example, let's consider, as an aside, let's consider this coalition. And that's going to be P sub 2, P sub 3, and P sub 4. And if we look at that, P sub 2 is worth 8. P sub 3 is worth 3, P sub 4 is worth 1. We go ahead, add those together and get 12, and that is less than or equal to our quota of 15, therefore not a winning coalition. I'm going to use the mathematical symbol for therefore, which is this triangular set of dots. So this is therefore not a winning coalition. Now you'll notice that in each one of these winning coalitions, P sub 1 is a key player, because P sub 1 is a dictator in this particular scenario, and for this particular scenario, P sub 1 is critical to the success of all of these possible winning coalitions. Now we note that there are 1, 2, 3, 4, 5, 6, 7 winning coalitions. Okay, so P sub 1 is a critical player for all 7 coalitions. Whereas P sub 2, P sub 3, and P sub 4 are not critical. To success. What this means is there are 7 possible winning coalitions, and since there are 7 coalitions and P sub 1 is critical to all 7 of them in order to achieve success, P sub 1 will have or has a critical count of 7. Whereas P sub 2, P sub 3, and P sub 4 have a critical count of 0. Now the Banzhaf power index is based upon this. We're going to have beta, and that will be equal to, and let's just call this beta sub n, will be equal to B sub n over T. Now what does that mean? Well, B sub n is going to be your critical count for each player. And T is going to be your sum of the critical counts. So in this particular case, T is going to be equal to 8 plus 0 plus 0 plus 0. I'm sorry, not 8. That would be 7 plus 0 plus 0 plus 0. And that is going to allow me to go ahead and create my power indices. P sub 1, which has a B sub 1 equal to 7 in this case. Remember, that's my critical count. And that will yield a beta sub 1, which is going to be equal to, as I said, B sub 1 over T, which will be equal to 7 over 7, which is equal to 1. You will reduce to either an integer or a fraction in simplest form. And then we'll do this for the remaining 3 players. Now remember, the remaining 3 players have critical counts of 0, so naturally it's going to follow that their Banzhaf power indices will also be 0. And we'll see that the power indices are 1, 0, 0, and 0 for player 1, player 2, player 3, and player 4 consecutively, or respectively, I'm sorry. Now, what happens if we don't have a dictator in the problem? That will be part B. Okay, so we want to find the Banzhaf power distribution when Q is equal to 18, which means that we'll rewrite the weighted voting system as such. And we'll see right away that now none of the players can be a dictator, because they can't sway the vote by themselves as far as just saying, I vote for this, and then the motion passes. Now what we're going to do is we're going to go ahead and understand what the winning coalitions are for this particular weighted voting system. Remember that this is the quota. These are the number of votes needed to pass a resolution. And these right here are the weight for each, or weights for each player. You'll note that I've written the first winning coalition here, P sub 1, P sub 2, P sub 3, P sub 4, because if I add my weights of 15, 8, 3, and 1 together, I get 27, which is greater than or equal to 18. This is a winning coalition. And now we're going to write down the remaining winning coalitions. Now you see that we've written down the 6 winning coalitions for this particular weighted voting system. And now I need to understand what the critical counts are for each one of the players. In other words, which of these coalitions has a critical player in that particular coalition. And so I'm going to list the coalitions, and then I'm going to list the players critical to success and determine if they are or not. So the first thing I do is list the first coalition. Or actually, yes. So now we determine which one of these players are critical to the success. Well, we'll notice that in this winning coalition, the player 1 is the only one that is critical, because we need player 1 in order to get through. So that is critical. But then we realize that 15 by itself doesn't get me to 18. And I'm going to need the help of one of these other two to get me to 18. This one is definitely not going to be critical. And I really only need either this one or this one to get me to 18 or beyond. So neither one of them are absolutely critical as long as 15 is understood to be critical. So we'll write down no for all three of these. Once again, we're going to look at this one right here, and we understand that for this one to work, once again, 15 is the only one that is absolutely critical. I don't need player 2 to vote yes if player 3 votes yes, and I don't need player 3 to vote yes if player 2 votes yes. Now for this one, this changes things a little bit differently, because if I get player 1 to vote yes and I get player 2 to vote yes, then I have a winning coalition. However, if player 1 votes yes and player 2 votes no and player 4 votes yes, I don't have a winning coalition. So that means that both player 1 and player 2 will be critical to the success. However, player 4 is not. Now for this one, we find out that we have player 1 and player 3 and player 4, and you'll note that player 1 and player 3 are critical to the success of the coalition. However, player 4 is not critical. And then we're going to look at both of these, and we need both to vote yes, and then also we need both to vote yes. So now we have our grid that tells me what's critical and what's not. And I'm going to go ahead and sum the y's. And these will be my b's for the power distribution. So this is going to be b sub 1, and if I sum this up, I have 6. This will be b sub 2. If I sum the y's, I'll have 2. b sub 3, I have 2 y's also. And then b sub 4, there are no y's, so that is going to be 0. And then I need to find the critical count, the total. So total, T, so for this case, T is simply going to be equal to 6 plus 2 plus 2 plus 0, which in this case is equal to 10. And that's what's going to be the denominator for my distribution. And now we go ahead and create the power distribution. Beta sub 1, which will be for player sub 1, we'll have b sub 1 over t. We know that b sub 1 is 6, t is 10. Now I'm going to go ahead and reduce this, because that's how you're going to need to put the fraction in. And then we're going to do that for the remaining 3 players. And now I have the Banzhaf power distribution for all 4 of these. Beta sub 1 is 3/5, beta sub 2 is 1/5, beta sub 3 is 1/10, and then beta sub 4 is 0. Now, these particular problems can be time consuming, especially in a problem like this, which has 4 different questions involved in it. And now I'm going to show you how to use the technology employed in the Java applet that comes bundled with the website. Now remember that when you're in the program, you're going to want to go ahead and go to Multimedia Library. We're looking for the Java applets. We'll left click that. We'll left click Find Now. And you'll notice that one of them is the Banzhaf Power Index. Left click that. Now, I don't know if this happens on all computers, but if I try to resize the screen when I'm in this particular applet, it freezes. So I do not resize the screen. Takes a moment for it to come up. And the instructions are here, but just follow what I'm going to do and you should be fine. We will left click the Banzhaf index, and then what we're going to do is have to input our values based upon the problem that we're working on. So let's bring that up, and now what we're going to do is we're going to be looking at creating the Banzhaf power distribution when Q is equal to 26. So we have to remember what our weighted voted system is when Q is equal to 26, and this is important. So we go ahead and we rewrite it, and we end up with 26 for the quota, colon, and then we write down the weights, 15, 8, 3, 1, and that's what we're going to be looking at. So now that we've got our applet up, we note that there are 4 players here. So I'm going to need a total of 4 rows. So I'll come over here to this button that says Add Row, and I will left click until I have 4 rows. Notice that I need to input the weight for each player, and that's what I'm going to do first. I'll left click in this, type in 15, then I'll left click in the next one, type in 8, left click in this one and type in 3, left click in this one and type in 1. Now in order for this to set properly, I'm just going to have to click in one of these other cells just to make sure that the weights are inputted correctly. And then I need to come down here to where it says quota. Follow the cursor, and I'm going to type in the quota of 26. And then simply left click compute, and now you'll see that we have a critical count column, a total value, and then the Banzhaf power percentages. However, we want to input these as fractions in my math lab. So what I want to do is go ahead and just copy this so that I've got a good copy so that I can use this information to help me draw, or I should say create my indices. Let me just minimize this a little bit, or make it smaller I should say, and I'm going to go ahead and understand that this right here is going to be player 1, this is player 2, this is player 3, this is player 4, and this will be my B sub 1, B sub 2, B sub 3, B sub 4, and then this is my total. And now I go ahead and create my betas. So beta sub 1 is going to be equal to 2 over 6, which will reduce to 1/3. Beta sub 2 will be also equal to 2 over 6, which will reduce to 1/3. Beta sub 3, once again 2 over 6, which reduces to 1/3. And then beta sub 4 is going to be 0 over 6, which is simply 0. And you have completed your power indices, and it takes a whole lot less work than trying to write it all out by hand. But now we do understand how it's done using the long method and then using the technology that is provided.